Okay, in calc, we're going to have 3 topics, people. 3. All we got to do is learn 3 things, and then we're done. Limits, which will take us about a couple weeks, maybe a month, maybe. Derivatives will take us through Christmas. Integrals will take us to the spring break. We're done. That's it. Okay, 3 things. So we're going to talk limits. And I was like, ooh, let's start first talking about where we see limits in our daily life. Like, you can only take 2. Where would be an example of only like a limit at a store? Like COVID. Do you guys remember when toilet paper, we had to limit people because people were hoarding it? Toilet paper. Your curfew. Do we have a curfew? Has anyone ever gotten in trouble with that curfew? You little angel babies. Speed limit. I don't know where there's ever a speed limit of 85 miles an hour, but we'll take it, right? So let's think this real fast. If an object is dropped from rest to fall freely and is falling at 16 t squared feet per t seconds, what's the average speed of a falling rock? We can do this. Average speed, so if we're looking for speed, is that the same thing as like a rate? Is a rate the same thing as a slope? Like rate of change? A little change in y over change in x? How would we get, what would be 1 and 4? Are those x's or y's? Time. But my f of x is my function with respect to time, right? So these are going to be my x's, and this is going to be my function. That's going to be my function, and then these are going to be my x's. So if I was trying to do slope, change in y over change in x, I need to evaluate my function, f of 4 minus f of 1, that's evaluating my y values, over my change in x values, 4 minus 1. You okay with this? Change in y over change in x? Yeah? Okay, we're getting a rate that this object is falling. Guys, I got to plug in 4 into my f of x function. What is plugging in 4 going to look like there? 16 times, thank you, Teddy, 4 squared minus f of 1? Was that Sev? Sorry, Sev. 16 times 1 squared, all over, what's that going to simplify to be? 3, thanks. Let's do some mental math. 4 squared. 16 times 16. 256. 256 minus 16 all over. 3. 256 minus 16. 240 over 3. 80. What would be my units if I just did, my feet over time? This is going to be feet per second, right? So this object is falling quick. 80 feet per second, okay? Question, this is kind of a fun thing of calculus. Where do you think on an AP free response question I could end? Red, blue, green, yellow, or black? Let's say they all were labeled with units. Don't worry about the units. Where do you think I could end and get all the points? Red. Can't end at red because that has variables in it. Blue. Is this equivalent to that? Yeah, and because it is, you guys can end right there. Can you do that for me all year? Absolutely. If this was a free response question, multiple choice, we'd have to get there because the answer is going to be simplified. If anything is free response, people, AP will take this, therefore I'm going to take that. Is this going to be weird when I'm like, Sev, just stop. Just stop there. Don't keep going. Because if Amina puts a 0 here instead of a 16, a 10 instead of a 16, she loses the whole thing. So let's just stop here. It's going to be weird, though. It's going to be weird adjusting to that. Okay. Did they ask for units of measure? They didn't. So we don't need this feet per second. If Amina would have put feet per second squared, we wouldn't get the point. They would take away from it. Even though they didn't ask for units, if we put the wrong units, then we lose the point. So I just put the units because we could, but they will, if it says indicate units of measure, they're giving you a point for it, so we should do it. If they don't say it, let's not do it just to make sure we don't mess it up. Capiche? Okay. What if I said, hey, if I told you to find the speed of the rock at the moment t was 2? I want to know the speed right at t is 2. If I had t is 2 here, and I used the same type of formula, And I only know, all right, they just want to know the speed when t is 2. Wouldn't that be f of 2 minus f of 2 all over 2 minus 2? Like my time is 2. What am I going to get there? What? Yeah, 0 over 0, right? I'm going to plug in the one thing and subtract that same thing. And this is called indeterminable form. We can't get anything from that. We don't know. But when that police officer pulls me over, he knows how fast I was going, boom, at one moment in time. And how did he do that? That's why we use limits. Limits are how we're going to do that. We're going to do the same thing here and here. If we're saying my initial time was 2 and my final time was 2 plus h, let's plug them into my function. So I just want you guys to say f of 2 plus h minus f of 2. Those are my 2 time values all over. What were my 2 times? We're going to say 2 plus h was my first one, minus 2 was my second one. I'm actually going to color code this just to make this a little f of 2. Let me say one more time what the heck we're doing. We're, again, using 2 points. One when x is 2, one when x is 2 plus a little on that x-axis, 2 plus h. We did change in y over change in x. What we got to do is we got to plug in our x value right here. If I plug that in, thank you, Jet, come on in. Wouldn't I have 16 times 2 plus h squared minus, okay, guys, I know we're almost out of time. Here's what I want to do. Just plug in 2 to my function, which was 16 times 2 squared, all over, what is this going to simplify to be? What's 2 plus h minus 2 going to simplify? Just an h. That's where we're going to end. So here we plugged in when x was 2 and when x was 2 plus h. And again, h is this distance on the x-axis, this little distance to give us 2 points to plug in. Those would be our x values, x and x, and then these are our y values at that point. We went ahead and plugged those x values into our function, and our function, just as a reminder, was 16t squared. And I plugged those x values in for my t there. You guys, let's go multiply this out. Can I deal with my 16 first? PEMDAS makes me do what first? What's in my parentheses, which is just a 2 plus h, and then what? PE. Yeah, take my exponent into account. So I've got to do, we've got 16 times 2 plus h times 2 plus h. I'm going to write it that way. Minus, let's go ahead and simplify that. What's 2 squared? 4 times 16? 64. You could write 64 there, which I'm going to do. Like we learned yesterday, could I have left this as 16 times 2 squared? Yeah. We could have, totally, because it has no variables in it. All over, we did x minus x, which 2 plus h minus 2. We said those 2's canceled out, so we just had an h there. I dig it. Okay, at this point, we could just distribute my 2 plus h times 2 plus h and ignore my 16 for now, or you could distribute that 16 in just to one of them, then distribute that there. I say let's not do that because distributing bigger numbers I think will be harder. Let's just deal with this first. Let's keep our 16 chilling. What's 2 plus h times 2 plus h? 4 plus how many h's? 4h. 4h, very good. Plus h squared. Then I got a minus 64, he chilling, all over h. Just have a little bit more. Sorry, this one does take up a lot of space. Now let's go distribute that 16. 16 times 4, we've done that once. 64. Great, thanks, Mar. Plus 16 times 4h. 64. You know it. Plus, how many h squareds? 16. You got it. Minus 64, all over h. Do my 64's cancel out? Plus 64 minus 64? I'm left with 64h plus 16h squared all over h. Lots of h's. Yeah. Oh, good call. Just to make it look like descending order, a little prettier. Would they call you on that? They would not, because again, bless up for AP, is 16h squared plus 64h equivalent to that flipped? Yeah. And if it's equivalent, they're good with it. Yeah. Great question. Guys, does everything have something that we could cancel out?
Yeah.
Does everything have an H? So fancily, we could write it this way, and you could skip this step if you want, you guys. But if I factored that out, you could skip this step, because what's going to happen? Psh, psh, that H cancels, right? Might some people do it this way? Psh, psh, psh. Same thing by crossing it out. What would it equal either way?
16H plus 16.
Yeah, either way. Now, you're like, what? They asked for the rate of this item, this object dropping. At the moment, T was 2. So here's the deal. Here's something new that we've never written before. We talked about the limit, and we talked about as the distance is we say the limit as the distance, H, approaches 0. And this is new notation where we're going to be practicing this a lot, but I just wrote LIM to signify limit as H and then an arrow 0. And again, that's talking about as that horizontal distance approaches 0, we get so close that this H value is approaching 0. It's basically 0. That means that you can substitute in a 0 there. What's 16 times 0?
0.
0 plus 64? 64 feet per second would be the speed of that item dropping at that one moment in time. We said between 1 and 4 seconds, the speed was 80 feet per second. And I'll give you a demonstration of that. And now it's saying at that moment, I gave you a lot of info to say, hey, R of T, which is the spread of a rumor, R of T is the number of people that have heard the rumor. T days since the rumor started. I don't like rumors. But the graph of the rumor R is shown, and the little tangent line when T is 4. 1, 2, 3, 4, boom. This is where it touches just once. And it says, can you think of an estimate for the instantaneous rate of change? You guys, this is just fancy for saying slope. This just is fancy for saying slope. Instantaneous rate of change at T is 4. What would be the best way to find the estimate of the slope when T is 4? The slope of this pink line. Do we think R of 4, the value of the function when T is 4, is going to get me the slope? When the function is just the number of people. The function is just the number of people. So is plugging in 4 there going to get me the slope or the rate of change? That's just going to tell me the number of people that have heard this rumor on the 4th day. So I'm not digging this guy. Boop. What about the slope joining between 1 and 4? So that's saying the slope here and the slope here. Would this give me the best estimate? That's option B. Between 4 and 8, I'm going to do that in blue. Between 4 and 8, 5, 6, 7, 8-ish. Would the slope here give me a good estimate? Oh, I just erased my point. Boop. Or would the slope between 3.8 and 4.2 give me the best estimate? I should have put that in a different color, black. What do we think, A, B, C, or D? D. Just as the closer we can get to that point, the more accurate it's going to be. I agree. And the smaller that little range could be. Okay, one more of these. A ball is rolling down a straight path. The position is B of T. The position is given for B of T. B is feet from the starting point, and T is seconds since the ball started rolling. Which of the following would be the best estimate of the velocity? They want a rate. Velocity is just a slope when T is 12.5. If I plug in 12.5 to this function, that's just getting me my position. My position there. What about change in y over change in x between 13 and 12 as my t? Or between 16 and 9 or 25 and 0? Thoughts? It's going to help me get the most accurate velocity at 12.5 seconds. You're saying right around it, just between 12 and 13. The closer I can get to it, the better. Agreed. So now, as we look at defining limits and using limit notation, this is new for us. This is kind of funky. This graph, do you agree, has a hole right here? So this graph has a hole, so let's go ahead and put down here, what's f of a's value? If there's a hole, f of a doesn't exist. It's undefined. Agreed. I'm just going to say does not exist. You could write undefined. Doesn't matter. I'm lazy, and D and E works faster for me. But I'm here to say this does have a limit. So let's practice this limit notation again. You're going to say the limit. And we're going to say as x approaches, so we've got this cute little arrow. And here's the x value that we're approaching. We're approaching a, so I'm going to put a little a. My function is named f of x. So I'm going to say the limit of my function f of x is. And you're like, well, I don't know. What I'm going to do is I'm going to put little dots here and say, all right, as my fingers come together, and I can actually have two lightsabers here. This is so great. As my fingers are on the graph and they approach A, do you agree that my fingers would come together? They'd come together at this point, even though this point doesn't exist? And what do we want to say it equals? Give me any letter out there. What letter do we want to say it equals? B. Boom. We're going to say, do you agree that my fingers would come together at the letter B? So that's what the limit equals here. The limit here is B. But notice that the function did not exist there, and that's okay. A limit is where your fingers come together even if the point doesn't exist. Doesn't matter what happens at the point, it's where your fingers come together. That's where these limits are, which is a little weird. So let's take a peek at this next one. What would be, let's go draw our little dotted line up here. Boop, boop, boop. What do we want f of a to be in this case? Is it defined? Is there a point for f of a? Yeah, what do we want to make that one? I don't care. What letter do we want to make that? T for Tatum? Let's do it. Boop, capital T. So in this picture, the value of the function when x is a, this is saying I want to know the point, is T for Tatum. But you guys, if we're asking for the limit, and I, again, didn't write these in for you because I wanted you to practice. You're going to say the limit as x approaches a, one more time, the same function we're talking about here. Do my fingers come together when I am on this function approaching a together? Do they come together? Yeah, they do. And if they come together, boom, the limit exists. And I'm going to have it be the same letter as the one that Cooper gave us, B. I'm going to say that limit on this one is still B because my fingers came together. On the third one, does f of a exist? Does f of a exist? Is there a point where a is? Yeah. What do we want to say this point is? F of a is, should we go T again? T for Tatum. F of a is still T. But what about my limit as x approaches a now? As I approach from both sides, do my fingers come together at a? Tatum's saying no, they don't. If your fingers do not come together, that limit of the function does not exist. So I might right here, I'm going to say my fingers come together. That's why that limit exists. If your fingers don't come together, nah, fam, doesn't exist. And they're just talking at this point. At A, they don't come together. What if I said the limit at 0 over here? If I set the limit at 0 over here, would my fingers come together at 0?
Yeah.
Yeah, my limit would exist there. What about at -1? Yeah, so I'm just saying at A, my limit doesn't exist. Cool? Okay, so for this graph, I said, hey, what's the limit as x approaches 3 of, and I'm saying that this graph is named S of x. As x approaches 3, if I were you, I put my fingers coming together, boop, at 3, what-ish do you think, what value-ish do my fingers come together at? Are we estimating? Yes, and that's fine. What do we think? 1.5-ish? I dig it. Let's go put that. 1.5. Mr. Richards, what about as x approaches 2? As x approaches 2, as my fingers come together at 2, do my fingers come together?
Yeah.
Yes. At what y value? 2. Now again, I don't care that there's a hole there because the limit is what happens as we approach that x value of 2. You're saying that y value is going to be 2. My question is, though, what's the value of the function at 2? What is f of 2?
1.
F of 2 is 1. How many people's minds just threw up? They're like, what? Don't forget, f of 2 is asking about the point. When x is 2, what's the value of the function? The limit is where my fingers are coming together, guys. Let's try one more time. What about at 4? The limit as x approaches 4. As my fingers come together at 4, where do they come together?
1.
At 1. What is f of 4?
1.
Yeah, would you guys agree this actually has the point 4 comma 1? This has the point 4, 1, so that's the value here. This has the point 2, 1. If this was closed in, would this represent a function anymore? Would it pass that vertical line test? No. So that's why they got to have one of them open. But I get, this is weird. This is weird and new. We've never done anything like this. Let's keep trying. From the table of values, which of the following is most likely true? So now I didn't give you a graph, but check this out. As my t values are approaching 2, what's happening here? As I approach 2 from the left, would you agree these y values are getting closer to 2? They're getting a little bigger. What happens when I come in from this side, though? Would you agree, these t values are getting smaller and, again, approaching a 2 here. Would you agree? It looks like a 2 would go right in between those. 1.99 to 2.01, I feel like there's a 2 there. Then what are my y values-ish coming together at, would you say? Yeah, wouldn't you say negative 3.4? We're getting closer to negative 3.5 on the left side. On the right side, we're getting smaller and approaching negative 3.5. Boom, that's how we would read that from a table. So 1.3 says, okay, at a certain x value, look at how I wrote all of these. F of 6, f of 4, f of 2. These are all points that they're looking for, you guys. Give me the point. When x is 6, what's my y? When x is 6, what is my y point?
4.
Yes, there's that point. This notation, f of 6 is 4, is the exact same thing as that, 6 comma 4. It's a point. What about when x is 4? What is the point when x is 4? What's my y?
2.
Close. When x is 4, 2, it's open circle. 5, exactly. Boom, right there. So f of 4 is 5, or you could say 4 comma 5. That's the exact same thing. When x is 2. When x is 2, you agree we got an open circle there, so that's not a point, and it looks like we then even have a vertical asymptote going on. Do you guys agree that when f of 2, there is no point? It does not exist. So that's not new for us. We're used to seeing points. This is what's new. So now notice I put these lines. We got to go down. Oh my gosh, and I've got this little notation. Holy smokes. Look at this big little exponent there. This little negative sign is from the negative side, or another way of saying from the negative side, if you're looking at a number line, on me, where's my negative side? This side, right? Which is to you, my left or right?
Left.
It's my left. So whenever we've got this little exponent of a negative, that is coming in from the left side. I need you to come in with your finger to the number 6 from your left side. So look what I'm going to do on my graph. I'm like, woo, I got to get all the way to 6. I got to get all the way to 6. I'm coming into 6 from the left side. Now, you might be like, what about all of this? Yeah, but don't forget, it's saying x approaches 6. Get really close to 6 from that left side. Where does my finger end up when I approach 6? Here's 6 from the left side. Where's my finger end up? What y value? 3. And it's messed up because there's a hole there. I agree, but don't worry about it. A limit is where as we approach 6, not the value at 6. So we're going to say 3. Right underneath that, it says, hey, as x approaches 6 from the positive side. The positive side of the number line is always on that right side, right? So this little positive is just saying, come at it from the right side. If I'm approaching 6, I got to get really close to 6 from the right side. Here's 6. I got to approach 6 from the right side. I got to stop at 6. I came in from the right side. Where's my finger end up? 3. It's the same thing. What do you think it means if I don't have an exponent? This just means come in from both sides. Approach 6 from both sides. So as I approach 6 from both sides, where do my fingers end up? 3. Boom, boom, boom. Feel good about 6. 6 is there. Love it. Let's go take a peek at 4 then. At 4. From the negative side, which just means to the left. Yeah, Lob. 4 from the negative side. How about 4 from the, here's 4. I got to come in from the negative side or the left side. I'm going to get really close to 4 from the left side. Where's my finger end up?
2.
2, and that's fine. My finger ends up at 2, boom. How about as I approach 4 from the positive side? 4 from the positive side, where does my finger end up there? 5. You guys, 4 from both sides then. If there's no exponent, I got to approach from both sides. Do my fingers end up together when I come in from both sides? And if they don't come together, limit does not exist. We channel the Mean Girls. Yeah? Okay with that, Harvey? Okay, let's try one more at 2. What about at 2? 2 from the negative side. I got to approach 2. Here's 2 from the negative side. Where's my finger going?
Negative infinity.
Negative infinity, right? I'm approaching 2 from that left side. I'm going to negative infinity. A limit, you guys, has to be an actual number. So you can write this, but it's not actually a number. So you can say that, or it does not exist. Either one of those works. AP will accept both of them. My answer keys, I've been trying to put both, but know if you put one or the other, you're good. Okay? What about 2 from the right side? Here's 2 from the right side. Where's my finger end up there? 4. So then, if I approach from both sides, 2 from both sides, 2 from the left, 2 from the right, are my fingers coming together?
No.
No. So that limit does not exist. Let's just try a couple of these, and then we're done. Then we're done. Here's a new pick. As I approach 1 from the positive side, here's 1. I got to come in from the right side of it and get close to 1. Where's my finger end up? 1. What do you say?
It's just like not labeled.
Oh, yeah, good point. This should have a 1 right there. That's a good call, Ritz. How about 1 from the left-hand side? Here's 1. I got to come in from the left side. Where's my finger end up?
0.
Yep, at a y value of 0. So then, what about 1 from both sides? Very good, because as I come from the left and the right, my fingers do not come together. They do not equal the same thing. But this is where life gets a little weird. What is f of 1? What is the point?
1.
Exactly. When x is 1, my y is 1. And again, that might help some people to say, oh yeah, that's a point. 1, 1. One more number of this, and then I'm going to give you some time. Let's just do when x is 2 here. Let's do when x is 2. 2 from the positive side. 2 from the positive side. From the positive side, we would get a 1. From the negative side, we would get a 1. So from both sides, do my fingers come together?
Yeah.
Yes.
So the limit exists.
The limit exists. And then what is f of 2?
2.
2. Or so most people just wrote f of 2 was 2, and that answer would be 2. That work? Okay, great. So here's what I'm going to ask. If you would go to your white homework packet, I want you guys to try pages 1 and 2. Pages 1 and 2.